Okay, this is going to be the second part of lesson 8.3 on trigonometry. So we're going to continue to solve the triangles using sine, cosine, and tangent. So remember, it's SO, CA, TOA. So for this problem, we have 38 degrees is given. We have 14 degrees is given. Now remember that z here, the easiest variable to solve for would be just subtract from 90. 90 minus 38, z is 52 degrees. Now you could add all of them up to 180 and subtract off. That's not really necessary though when you know the 90 degrees is already 90 out of the 180. Okay, so it doesn't matter if we find x first or if we find y first, but if I were to use 38 degrees, 14, and x, let's go ahead and label our opposite and our adjacent and our hypotenuse. The hypotenuse is always across from the right angle. The opposite leg to 38 is 14. The adjacent leg to 38 is x. Okay, so we're looking for 38 degrees, 14, and x. That's opposite and adjacent. Opposite and adjacent is tangent. Okay, so our equation will be the tangent of 38 degrees equals the opposite, which is 14, over the adjacent, which is x. Now, this one looks a little bit different. Why? Well, the denominator is the variable this time, so I want to get that x out of the denominator. So I'm going to go ahead and multiply both sides by x because that will make the denominator disappear. If you multiplied both sides by 14, you'd end up with 196 on the top and x still on the bottom. Okay, so to get rid of the x, we're going to multiply both sides by x. Now, we have x tangent 38 is equal to 14. To get x alone, we're going to divide both sides by tangent 38. That's just a number, right? So it's like if you had 5x equals 14, you would divide both sides by 5. It's the same thing. Tangent 38 is just a number. We want it to cancel, and that's what we'll be typing in the calculator. Okay, 14 divided by tangent 38. 14 divided by the tangent of 38 degrees is approximately, maybe some purple, x is approximately 17.9. And z was 52. Okay, now again, we could do the Pythagorean theorem to solve this if we wanted to. My preference is to use Trig because I think once you're comfortable with doing trigonometry, it's actually faster than doing the Pythagorean theorem. And I also think it's good practice to do trigonometry instead of the Pythagorean theorem. Okay, so I'm going to use the 14 that we were given, the 38 that we were given. I'm going to find y. So y is using hypotenuse and opposite. Well, hypotenuse and opposite is sine. Okay, so we'll do the sine. I'm going to write over here and then transfer it over. The sine of 38 degrees is the opposite, which is 14, over the hypotenuse, which is y. The sine of 38 is 14 over y. Now again, we want to get the y out of the denominator, so we're going to multiply both sides by that y. That'll cancel. And then we're going to divide both sides by sine of 38. If you need to write this step, y sine 38 equals 14, and then do the dividing, that's okay. Do that. All right, after you do this a few times, it might be kind of easier to see what you're doing. That will cancel. That's what you're typing in the calculator. 14 divided by sine of 38. So y is approximately 22.7. I just want to show you another way, if it makes more sense to you to do this. This is another option for solving that equation. If you have sine of 38 is 14 over y, and you're like, I'm not really sure what I want to do to that, if you put that over 1, that's just a proportion. So if you would rather just throw it over 1 and then cross multiply, it'll turn into y sine of 38 is equal to 14. And then again, you can divide both sides by sine 38. And then you'd be typing that in the calculator just like we did up there. Oops, up there. Okay, so that's an option. If you think it's easier to turn into proportion, then just do that instead. Sometimes students get stuck looking at that, not really sure what to do, and they got that y in the denominator and they don't know how to get it out of the denominator. So just another option. Okay, and then the last idea, finding angle measures using trigonometry. Finding angle measures using trigonometry. Okay, so again, if you do something else and come back and start doing trigonometry, if you haven't changed your calculator, no one used your calculator, it'll still be in degree mode. But you just want to make sure that your calculator is in degree mode before you start doing trig. Okay, so again, there's different ways of measuring. Radians and degrees are 2 different ways. So it's just like inches versus centimeters, just 2 different ways of measuring angles. You'll do a lot of radian work in pre-calculus, but we'll only be doing degrees in geometry. Okay, so to find the degree measure of an angle, when you know the sine, cosine, or tangent, you're going to be using the buttons that look like sine -1, cosine -1, tangent -1. Okay, those are inverse trig functions. Okay, so this one you say inverse sine, that one you say inverse cosine, that one you say inverse tangent. Okay, those are inverse functions. So it's just like how adding and subtracting are inverses, or square rooting and squaring are inverses, or multiplying and dividing are inverses. The inverse of taking the sine of an angle is doing the inverse sine of the answer. So first, on a graphing calculator, there will be a second function. Sine will give you inverse sine. So that also happens a lot on scientific calculators. If you look at the row where the sine, cosine, tangent is, that up above it is like that orange sine -1. That means you hit the second function button and then sine. Okay, on some scientific calculators, there might be a menu where you have to scroll through. You might have to scroll through like sine, cosine, tangent, and then you'll come to sine -1 and cosine -1 and tangent -1. So it just depends on your calculator what how you'll choose that, but it'll be sine -1 is what you're looking for. Okay, so when you see this, it's saying, all right, I'm giving you the answer. I'm thinking of an angle whose sine is 0.7245. So what we will type in the calculator is, okay, I'm going to undo that. I'm going to take the inverse sine of 0.7245. Okay. Inverse sine of 0.7245. A is approximately, and I said round to the 10th. So A is approximately 46.4 degrees. Okay, the cosine of B is 0.2493. That means I'm looking for the angle whose cosine is 0.2493. So I'm doing the inverse cosine of 0.2493 to go backwards and figure out what the angle is. So second function cosine, 0.2493. Inverse cosine of 0.2493 tells us that the angle is approximately 75.6 degrees. Now again, we're finding angle measures, so these should have degree marks on them. Okay, the last one, we have an angle whose tangent is 9.4618. So our angle is the inverse tangent. We're going backwards, so we're undoing tangent by doing inverse tangent of 9.4618. Inverse tangent of 9.4618. C is going to be approximately 80 84.0 because it's 83.9669. I'm looking for the 10th. That means I'm looking at the 100th position to decide if I round up or round down. Well, since it's above 5, I'm going to round it up. And like that takes the 0.96 and bumps it up to 4.0. So angle measure C, 84.0 degrees. Okay, these last two problems are going to be mixing together what we've learned. So notice that I haven't given you very much information. You have a right angle, you have two sides of this triangle, and I want you to try to figure out the other angle measures and the side lengths. Okay, so let me go ahead and put, I'm just going to write like X on that side. So could we do the Pythagorean theorem? Sure. Could we find an angle measure and then do trig? Sure. But since we're comfortable with the Pythagorean theorem, I think we should go ahead and do that. Leg squared plus leg squared equals hypotenuse squared. Okay. X squared plus 29 squared is 841. 34 squared is 1,156 minus 841. X squared is 315. I do not think that that's a perfect square. But, okay, so let's see, 315 divided by 5 is 63. Okay, so let's do this. We're doing the square root of both sides. So X equals, let me see what I said, what I told you. Oh, you know what? I didn't even ask you to find the side. Well, look at that. I was going to say we can round that off or we could give an exact value. I didn't even ask you to find the side, but let's go ahead and finish that. So X would be approximately 17.7. Okay, so let me take that and shrink it down over here on the side since I didn't even ask you to do that on this problem. All right, find the measures of angle T and angle R. Okay, so for angle T, I've got 29, I've got 34. I'm going to start by saying across from angle T is our opposite. Our hypotenuse is always across from the right angle. And then our adjacent to angle T is the other leg. So across is the opposite, and then beside it's now the hypotenuse is our adjacent. Okay, I'm always going to write SOHCAHTOA to help us remember what we're doing. Okay, so in relation to angle T, I've got T, I've got opposite, I've got hypotenuse. Well, opposite of hypotenuse, that's going to be sine. Okay, so the sine of angle T is equal to, the opposite is 29 over the hypotenuse, which is 34. Now, this is what we were just doing up above, right? If I tell you the sine of an angle is a number, not always in decimals, but it's a number, then we can find T by using the inverse sign. Inverse sign undoes the sign. So 29 over 34, the inverse sign of 29 over 34. Inverse sign of 29 divided by 34. Rounded to the nearest tenth, T is approximately 58.5 degrees. Okay, now, this is about 58.5. What could we do to find the other angle measure? Well, we could say, let's see, look at angle R here. We could say angle R and then use our two angles there, and then that would make that one opposite would be over here, and adjacent would be the 29, and the hypotenuse would be the 34. Okay, so if we did angle R with trigonometry, we could say adjacent over hypotenuse. 29 over 34 is the cosine of angle R. However, right, that'd be cosine, adjacent hypotenuse. However, we already know that angle measure, right? So let's do what we did before. Easy. we'll just say R is going to be 90 minus angle T's measure, which is 58.5. Oops. 90 minus 50, 58.5, 31.5 degrees. Now, technically, it's approximately, but not really that picky about that. Okay, so could you do trigonometry? Yes, you could do the cosine of R is adjacent, which is 29, over hypotenuse, which is 34. Cosine is adjacent over hypotenuse. And then R would be inverse cosine of 29 over 34. Type that in your calculator. Inverse cosine 29 over 34. 31.5. Okay, it would give you the same answer. Extra work, not necessary. 31.5 degrees. It would work, just not really necessary. Okay, for the last problem, I want you to try this one yourself. And then after you finish that, then you can submit this to Schoology. So it's really important that you show a trig equation, show what you're going to type into the calculator, and then show your answer correctly rounded with a label. Okay, if you don't do those things, it's really easy to mistype something on the calculator, your answer is completely wrong, and we have no idea what you did. Okay, so make sure you're writing a trig equation, you're showing what you were typing into the calculator, and then your final answer rounded correctly with the correct label. All right, that's the end of this lesson.